Welcome to today's webinar, Attacking and Defending Kubernetes with Jay Beale. This is the third monthly webinar of 2019. Please be sure to check out our previous awesome webinars, one by Larry Pesci and one by Adam Crompton. But today, without further ado, I pass it on to the master of Kubernetes and all things cloud related, Jay Beale.
Thanks, Mike. Well, the most I can claim on the mastery is a black belt, which I think anyone here who practices the martial arts knows that your black belt means that you're now ready to start learning. It also means you're ready to start teaching, but yeah, that's the next place we are. So, hi, I'm Jay Beale, and I'm going to talk about attacking and defending Kubernetes. So let's start out. Here's our title slide. Here's my bio slide, but everyone knows bios are seas of text that no one can really read much of. So there's my real bio slide. This says that I've worked on a bunch of different things over the years. I'm a founder at InGuardians. I've written some books. I did some work with the Center for Internet Security, creating their first Linux benchmark and scoring tool. I have a family that I love very much, and I like to rock climb. And I have a class every year at Black Hat, and this one's on not just Linux, but Linux, Docker, and Kubernetes. So anyway, let's get straight into it. So here's where we're going to go today. We're going to talk about what Kubernetes is, what it does. I'm going to show you attacks on Kubernetes clusters. I'm going to show you some defenses, and then I'll talk to you about some more defenses, and we may have a treat. So let's get right into it. So this is kind of our quick introduction to what Kubernetes is. If you already know this part, don't worry, it's over pretty fast. So the first question that kind of comes up is like, okay, where the heck did this thing come from? And if you follow the press, Google back in 2014 said in a GlueCon presentation that everybody, that tons of news outlets picked up, that they launched 2 billion containers per week. That was back in 2014. Who knows what it is now, but 2 billion, and that comes out to about 3,300 containers per second. So every second, on average, they're starting up 3,300 programs, each in their own container. Now, how many? Okay, that's how many containers. What about servers? So they did that with 2.5 million servers. That was the number we had back in 2016 by a Gartner estimate. So now, what I want you to understand is, if you're going to launch that many containers, if you're going to be launching that many programs, if you've got that many machines, one of the biggest things you have to deal with is failure. Right, so hard drives had an annualized failure rate back in 2016 of 1.95% per year. So that means at one drive per server, that means they were dealing with 133 drive failures a day, or one every 9 minutes. That means if you're Google and you want to start a program, what we'd call a piece of work, a workload on a computer, there's a good chance that that computer's hard drive may be failing because you're dealing with one failure every 9 minutes. So suppose you're Google and you basically have to get programs. Some of them are internal, some of them are, backing Gmail and, opening up your inbox for you. Others, or some of those are external that way. Others are purely internal. They have a huge data set and they want to figure out, they want to answer some question. Maybe it's a short running thing, maybe it's a long running thing. You've got to manage that. What do you end up wanting to create? What features do you need? Well, their answer was basically the Borg. The Borg was a predecessor to Kubernetes. And so these are the kind of features you end up with if this is what you're trying to accomplish. You're basically trying to get a software-defined data center, and you do that by container orchestration. So you're trying to be able to do these kinds of things. You're trying to be able to basically figure out 3,300 times per second, which machine should I put that workload on? And heck, since one of those machines is going to fail every 9 minutes, let me go and figure out how many machines I should put it on so that if one of them crashes, the work still gets done and it still gets done on time, and I don't have any uptime and I don't have any downtime due to it. Okay, so I have to be able to handle some self-healing. The bin packing is, how do I figure out how to put all these pieces of work onto, which of those 2.5 million machines has enough free RAM or CPU or what have you to deal with this. And there's a whole bunch that you do otherwise, but basically what you come up with is the modern hyperscale data center, and that's container based. Even if we're dealing in cloud, you end up basically in this place where you're sticking all of your workloads into containers, and those containers are meant to be easily replaceable. They're meant to be ephemeral. It's meant to be that you say, I think I need 5 copies of this thing running, so that I can handle the load. But heck, if more users hit that service than I expected, like, kick it up beyond 5. Don't go as high as 200. But I know that I can't handle a minimum load without having at least 5. So make sure there's no less than 5. Kubernetes basically, its whole purpose is to manage all that for you. That you say, this is what I need, and it says, okay, I'll figure out where to put it. I'll keep watch on it, make sure it keeps going. So I'm going to give you a little bit of a few of the Kubernetes components that we attack as attackers real soon. And to get on the way there, I want to give you just a quick table of contents and a quick list of terms. So the first term we need, and these graphics are borrowed straight from the CNCF, the Cloud Native Computing Foundation's website. Here's our terms. Our first one is a pod. So a pod is the smallest unit of computation or compute in Kubernetes. It's not a container. A pod has one or more containers in it. The idea is that I might actually put 2 programs in the same pod. And so Kubernetes just says, fine, the pod is the smallest unit of compute. It may have 1 or more containers in it. You're kind of seeing 4 examples here of pods. If I look at the one on the right, it's got 3 containers running in it, their applications, and it's got 2 bits of storage, volumes. And so the containers in a pod, they all share an IP address. They all are guaranteed to be on the same host, and that's this pod basically expresses these things have to be on the same host dependency, and they may have access to the same volumes. And we're going to see that some more on the attack side. We're going to talk about nodes. So nodes are machines that run that are in a Kubernetes cluster. Those nodes, at minimum, the worker nodes will have to run a kubelet. And that kubelet ties the machine into the rest of Kubernetes. We have a container runtime, like Docker, something that basically stands up the containers on instruction from the kubelet. And then we have what's called a kube proxy, and it's there for services, which we're going to talk about on the very next slide. Last big term here we have is a service. And a service is basically a software-defined load balancer. You say, okay, I'm going to stand up 5 copies, but it might turn into 10, it might turn into 100. I'm going to stand up 5 copies of this container image, standing up that many copies of this pod on different hosts. Well, now how do users or how do services, how do programs that need to reach this service, how do they reach that program? You basically stand up a service, and that service, you say, for any pods that match these labels, and in a container environment, the idea is the containers are ephemeral. You can't refer to them by name. You can't really refer to them by IP address. All of that's changing. All that's expected to change. Among other things, it's expected to change because you don't know when the hosts are going to fail, but also for lots of other reasons, like getting new versions up constantly. So we have a service, and a service is a load balancer. That load balancer basically says it creates a DNS name, an IP address, and a port, where if you are in the cluster and you connect to that name and port, you end up on one of the containers that's running that program. So that's a service. Last term is a namespace, and we're going to definitely see this a lot in the first demo. So a namespace is a logical grouping for Kubernetes objects. If I create a bunch of pods, they'll be in 1 or more namespaces, and those namespaces will separate out departments or development groups or tenants in a multi-tenancy environment, it could actually separate companies. If those companies are competitors, I don't know that I recommend that just yet. Give them different clusters, but one day we might not be saying that. Every cluster starts out with at least 2 namespaces. One's the Kube system namespace where all the parts of Kubernetes run. Yeah, that's right. It's kind of freaky cool, but all the parts of Kubernetes run in pods, run by Kubernetes. Huh, okay. And then we've got a default namespace where things will be in. If you don't tell them if you create things on the cluster and you don't tell what namespace you'd like them to be in, they'll end up in default. So there's our quick glossary, a little reminder of those terms: containers, pods, images, nodes, namespaces. So as I said before, and you're going to see this a bunch as we do our attack work, Kubernetes is all about the declarative model. You don't say that you'd like it to, you don't say, hey, go and stand up this container on this machine. You say, I have this container image. I'd like it to be running on 3 or more machines. You figure it out. And Kubernetes basically takes on responsibility for keeping that container staged to as many separate machines as possible so that we can handle machine failures, and it watches for the containers for the programs to crash, and when they do, it replaces them. It's basically there to kind of take all of the trivial stuff, as it were, or otherwise not scalable by humans stuff out of the equation for you. So last bit of Kubernetes intro, and then we get to the attack. So Kubernetes has a number of parts. These are the parts we want to attack. One is the API server. So you have an API server. Its purpose is to get those declarative configuration, those YAML files or those JSON files or those curl requests or what have you, and direct the other components to take action. And those other components involve controllers and involve a whole bunch of parts. We're going to keep talking about the parts that we'll attack directly. So we'll attack the API server. We'll attack the kubelet. We talked about that. It runs on every node in the cluster, connects the cluster itself to the Docker on each node. We have a container runtime, which is often but not always Docker. That's the thing that pulls the container images from a repository and deploys them as containers by telling the kernel to do it. We have an etcd server that retains the state of the cluster. We don't usually get to attack that directly, but when we do, it's so nice. We have a Kubernetes dashboard, which I got to say, hopefully you're not running if you're a defender. If you're an attacker, hopefully you find this. This is how Tesla got their Kubernetes cluster turned into something that was running crypto mining. Somebody found the dashboard and it lacked authentication. So the dashboard is basically a web interface. And then we also have the metrics components and cluster services that we might use to get useful data about the target, or if one of them has a vulnerability, just use it to get command execution. So there are more components. These are the ones we're going to hit today. So now let's get into the attack side. So an attack on Kubernetes is going to start whenever, at InGuardians, we do a ton of penetration tests on Kubernetes clusters, and we almost always start from the perspective of a compromised pod. We say, what if you'd been running, WordPress on here, and as the attacker, we found a WordPress vulnerability, and we found ourselves not just on a virtual machine, but instead in a container in a Kubernetes cluster. What can we do? There are other reasons you might be a bad actor on a cluster. Another one might be you might phish or compromise a person who had access to a pod running in the cluster. You might be a threat actor who is you might be an insider who's looking to escalate their privileges. It's hard to tell the difference, honestly, between a phished insider and a hostile insider, by the way. So if you're that kind of threat actor, what would you be trying to do? I know the answer is get access, hack all the things, but how might you do that? So you might use the access that's provided by your pod that's in the cluster to access other services, to look for the other things that are running in the cluster that you now have access to that you didn't before you were in the cluster. You might try even attacking the other containers that are in the same pod as you, because containers that are in the same pod, they share an IP address. There's basically no firewalling between them. They often share storage. They often share other kinds of privileges in the cluster, and you're going to see that in the attack. You might make requests on the API server. You might make requests on the kubelet. And in those cases, you might say, run commands in a different pod. Sometimes even run them interactively, and we'll get to see that. It's really fun. You might start a new pod up that has more privilege. Often, one of the classic oldies but goodies is that you start up a container that can access the file system of the host of it's called a node here, of the node that it's running on. And if you can do that, you can compromise the node. You might gather secrets that Kubernetes is providing the pods. You might connect to the dashboard, perform some actions. You might interact with the etcd server and try to change the cluster state. You might interact with the cloud provider, and we'll do that too, to basically get the cluster owner's account and use it for things. So with that said, I want to stop talking theory now and get straight into the practical attack. So I'm going to show you some demos. This first one is an attack on a multi-tenant Kubernetes cluster. I record all my demos, and that could arguably, because I'm a slower typist than I am narrator, or alternatively, it could be because I make lots of typos and I'd love to avoid them by just restarting the recording. So I'm going to show you next. The Kubernetes multi-tenant attack. So in this cluster, we've got two departments. We've got a marketing department, which is what we're going to compromise, and we've got a development department that we need to get to. So let's go straight into our video. And I'm going to switch applications, and here's our video. So this one says this is a WordPress instance we're looking at. It's WordPress running on port 8000. Nobody ever finds you on 8000, don't worry. And it says multi-tenant Kubernetes CTF. So this is built as a capture the flag exercise. And I like to build capture the flag exercises, especially for talks and for training. If you're in one of my training classes, we'll talk a little bit, the same way we did at the beginning of this, about how to do things. We'll do it more slowly than I'm going in a 1 hour talk. But and then we stop talking and we attack, and we basically have a capture the flag exercise where you're going through collecting flags as you compromise a system more and more deeply. And then we turn around once we've fully compromised it and use the same access that we got out of compromising it to do what lots of attackers have done when they want to keep a host that they've compromised. We'll go and basically defend it. We'll create some proactive defenses, the same kind that we might have had beforehand, and see how those proactive defenses break our attack. And we do that like totally hands-on. So that's kind of what you're getting a taste of right here. So here we are. This is my CTF, and I'm going to take this WordPress host, and I've got a Kali system. The video is done from a Kali system. I like to do everything I do in talks and training on Kali because it's something you can all download, and you don't have to configure it to basically be able to start up and follow right along. So here's my Kali system. I've got a shell. I have that browser we were just looking at. I'm going to fire up Dirbuster. And Dirbuster is one of the first things I used against a web application. And what I'm going to do is basically I'm looking for the pages. I've got the pages that I see when I view source and click through the app, but I want to see if there are any other pages that are there, if there's any other content. So I tell Dirbuster what the URL is. I set up a dictionary, and on Kali Linux, I go to user share, and I'll find a word list. So I'll go to user share Dirbuster, and I'll find my word lists, and I'll choose a word list. And then I'll kick up my threads so that I've got, so I'm gonna make about 500 requests per second with 20 threads. I tell it not to be recursive so we get results a little faster, and I hit start. And seconds later, I find these are my results. It says, okay, you've got a bunch of, the normal WordPress login, WordPress content pages, but you've also got a backdoor.php. Oh, backdoor.php isn't normally part of WordPress. It sounds like, well, this is a normal WordPress instance in that it's already been compromised. Cool. Well, why go and compromise it ourselves? That's going to take a while to figure out how to do if we can just use somebody else's backdoor. So I'm going to stop this Dirbuster run, and I'm going to connect to that backdoor. So I'm just going to add onto here backdoor.php, and I find a very comfortable backdoor that you can find on Kali Linux. Anytime you got PHP execution, this is something you can run. And so it says you can execute commands and upload files and so on. So I'll say run ID so I can see what user I am. And it passed by really quick because I clearly edited that video too tightly. But if you saw it flash, it said that I was the dub data user. And so what else do I want to do? So what I'm going to do now is I'm going to stop and close down my Dirbuster. And I can just run commands one at a time through this, and I'll do this a little bit, but what's really comfortable for me is basically to get a remote access Trojan. And if you've used Metasploit, you've seen a interpreter, so I'm gonna get a interpreter uploaded. So the first thing I'm gonna do is basically go over to a shell. I'll stand up a quick web server with Python. It's a nice little one-liner. The Python module, it's a standard module that comes with Python, simple HTTP server, and say, Python, I'd like you to start listening on port 9999. And we'll serve files out of there. And so now I'll set up a curl command against that IP address, the IP address of my Kali box, and I'm going to ask for a binary called Mrs. Bin that I've created already with MSF Venom, and that's an interpreter reverse shell binary. So I'll pull that down to this system that I've compromised, and I'll set its permissions to be executable because I need to run that. And then I'm gonna get a copy of kubectl there too. So I'll take that URL and also add in kubectl. Okay, and I see from my web server output that Mrs. Bin and kubectl were both pulled. So now let's go back to that back door and let's make sure they're there. ls-l. Hey, there's Mrs. Bin and there's kubectl. So let's go and basically run my Mrs. Bin, and that'll give me a connection to my Metasploit console. Oh wait, I better set up a Metasploit console. So I'll go over to my shell window, and I'll set up MSF console. And I've got a little multi-handler. It's like 4 lines of what you type in a Metasploit to set up a listener for Mrs. Bin. And I'll run Mrs. Bin. I go over to Metasploit and I see there's a new session opened. So I'll interact with that session and I'll ask for shell. And print working directory, looks like I'm in var.html, exactly where the backdoor was and where WordPress was. So that's cool, great. kubectl is in there, that's nice. I'm gonna run a mount command, and when I run mount, I notice I'm basically in a container. And I'm not just in a container, I'm in a container running on Kubernetes because there's a service account directory mounted in. So let's continue working with that shell. I clear the screen and I do an ls and I see that first flag. So I take a look at that first flag and it says, hey, congratulations, you found the server's backdoor. You're in a cluster. It's time to bust a kube. Can you find your way to another pod to find another flag? Okay, so it's basically saying you're in a pod, great, you got RCE, but it's time to move to another pod. Can you find a way to do that? And okay, cool. Well, let's see what we can do. We've got a copy of kube control. Some people call it kube cuddle. I like kube control. I'm going to do a quick little mount command and get that service account directory. And I'm going to switch into that service account directory. So run secrets Kubernetes IO service account. And this is the default behavior that a service account is mounted into every single pod. So I'll see in here that there's a CA cert, and that CA cert is the certificate authority cert for the cluster. I'll need that. See what namespace I'm in. Cat out namespace, it says your service account is basically in the marketing namespace. Okay, cool. How about that token? There's your service account token. I can use this and pass it through kube control to run commands against the API server. Well, that'll be really useful. So let's find out where the API server is. So I'm going to go back over to that web shell. It's just that first process in a pod or in a container that's in a pod that's going to get this, but you get a bunch of environment variables that tells the program running in that pod, hey, here's what you need to know to use Kubernetes to go and basically use the cluster, because we don't know what your needs are. So here's where the API server can be found. So we take that environment variable, and that's what we're going to need, this 164.0.1 on port 443. And what I'm going to do, I'm going to clear the screen, and I'm going to set up a kube control command, and I'm going to alias kube control to use that specific copy of kube control. It's the only one there, but it's not in my path. Pass in the token that you find in that file. So my token is, has in it the results of catting out the token file. Find the certificate authority at this path, and use the namespace that's named there, and use this server. So now every time I type kube control, it's going to be all of this. So So now all my commands get much easier than having to copy and paste all of that over and over again. So the first thing I do anytime I get kube control into a compromised pod is see if I can get pods. That tells me usually, because you almost always can, and that tells me if kube control is working and if my service count works. And cool, it gave me 2 pods. So the first one was WordPress and then some junk, and that junk is part of the way Kubernetes does deployments. So we won't talk about that. And the other is WordPress MySQL. I run hostname and it says you're in WordPress. Cool, we're kind of in that front end pod. Now, if we want to move pods, the most natural, easy thing is we could do kind of the equivalent of a Docker exec. We can do a kube control exec and exec into that other pod. It's that WordPress MySQL pod. So let's try and do that. Let's take the pod's name, kube control exec -IT. I think of that like interactive terminal or interactive TTY, the name, and then a program I'd like to run interactively. I'd like to run a bash shell if there's one in there. Ah, nicely, there's one in there. Let's make sure I'm in another pod now. Type hostname. Ah, I'm in WordPress MySQL. Well, that will do. And now I find another flag. So I'll clear my screen and I cut out that flag and it says, hey, you found your way to another container. And what's even cooler is that means you found your way to a new virtual machine. Moving to a container often means switching hosts. Sometimes it means switching data centers or continents. So now I want to see what you can do next. Your end goal is to get to the developer's non-containerized host. And to get there, you're going to want to see if you can hop tenants. Now, tenants in Kubernetes are generally separated by namespaces. So just like we were just told, okay, there's nothing more for you in this pod, we're now being told there's nothing more for you in this namespace. See if you can get out of this namespace. So let's see. Let's run my, let's try my kube control, get pods. Oh, darn it. My service account, this is marketing MySQL. I must have been in marketing something else, maybe marketing front end or marketing WordPress before. This service account isn't allowed to list pods in the marketing namespace. Okay, well, let's see if there are other things I can do. Let me try get nodes. Oh, cool. Get a list of nodes. This is a 3-node cluster, not very representative, but it's a 3-node cluster, and I can find the master at this IP address. Well, cool, that'll do. 172.20.47.208. So I'm going to try a different kind of attack. I'm going to go and talk to the kubelet. So we've been running commands against the API server, basically sending it kind of curl requests, or we can send it JSON or get back JSON or send it YAML. So we're now going to try making a request directly against one of the kubelets, and not just one of the kubelets, but the kubelet running on the master. If we can do this, this actually is kind of a game over for the cluster. But let's try this out. So I'm going to run a curl against that IP address. And the kubelet listens on 2 ports. It listens on 10.250 and 10.255. So we're going to say on 10.250, we'd like to ask for a list of running pods. And instead of, and when I get this out, I get a big pile of JSON. That's our default. And this shows me all the pods that are running and tells me information about them. Now that's hard to read. So I'm going to get a program called JQ for JSON query. And I'm going to say, I would like to take that running pods output and just see a list of, for each pod, a namespace and a name. So these are all the pods, just the name of the pod and its namespace. And you see a bunch of kube system, the different components of Kubernetes. But the cool thing is that we also see there's another namespace called dev, and there's a pod called dev pod. So let's run that same command again with the JQ, but this time we won't ask it to only show us part. We'll just say show us everything about the pods. And I'll get lucky, and it turns out my first screenful has dev pod on it. And here's the dev pod. This pod has 2 containers in it. One's called dev sync, the other's called dev web. And this is a pretty normal pattern to see. If there are tons of times where you have a web server and that web server is basically running that web server machine, virtual machine or what have you, is running a web server program, and then it's also running some kind of synchronization program that pulls down content, and that might be rsync or an SSH, might be something else. The cool thing is for us as attackers is we'd love to get into that dev sync container. Because that dev sync container probably has credentials used to pull data used to pull web content in for dev web to show. So let's go and take a look. Let's go and see if we can try to ask the kubelet something else. Instead of this time asking the kubelet for a list of running pods, we're going to actually pass in a different kind of API request. This is so cool. We're going to pass in run, and then we'll name the namespace dev, and then the pod, dev pod, and then the name of one of the containers, dev sync, the one we think has the key in it, has credentials in it. And as data to this curl request, we pass in command equals ID. And we get a 126, we get an error. I'm just going to tell you that basically means it didn't work because there's no shell there. So let's try something else. Let's try the other container that's in that pod. So dev pod, and we'll do dev web. Same thing, command ID. And it says, oh, you're rooting there. So that means I can run commands. If I use this curl request, I can run commands in this pod that's in this other namespace on this other machine, the Kubernetes master node, and I get root privilege in there too, which is not as neat as when it's on a whole system, but it's still useful. And so I'm going to pass in another command. I'll pass in ls, and it says there's a flag. So let's do that same kind of curl command. Let's pass in cat out that flag. And it says, whoa, no more wasting your time in the marketing department. You've busted your way into development. Can you take over the development department's non-containerized machine? They're big fans of the Matrix, so it's named mainframe for the machine's mainframe that's shown in the third Matrix movie. Now, I know I just offended some of you. It's an important religious belief for you that there's no second or third Matrix movie, and I understand and I apologize, and I'll make sure that in future demos I don't do that. I just found out about that religious belief, and I want to respect it. I don't agree. I believe there are 3 Matrix movies, not 3 equal movies, but 3 movies. So now let's try something else. Let's run a command in that dev web pod. And in dev web, let's try running kube control get pods. And it says, oh, sorry, your service account dev app isn't allowed to list pods. Okay, let's try something else. Let's try get secrets. Oh boy, we're allowed to do that. So here's the cool thing. Listen, if you've got 2 containers running in the same pod, they generally have the same service account. If they have the same service account, well, Kubernetes maintains a bunch of secrets for us in a way that it calls opaque. That sounds mysterious. And one of those secrets, those secrets will be the service account tokens, but we clearly already have the service account token we needed there. We might find that other default token useful, but I'm seeing a couple other secrets. One's called mainframe login and one's called SSH key. So let's keep running commands through our curl command, and let's pull the contents of one of those secrets. So we'll do kube control get secrets SSH key, and we'll ask for it to be output in YAML. And here's our opaque secret. So if we look at that data, what does that look like? Well, it looks a lot like base 64 to me, and it should. That's the default way of doing it. I just wanted to feign surprise to make it more fun. And there we go. It looks like it's an SSH private key. Well, let's look at that other secret. That other secret was the mainframe login. So let's get that secret. Mainframe login -o YAML, and we'll grab that data. And if you're feeling like this could be parsed and made into a tool, yeah, it's true. I'll show you one later on. So there we go. We base 64 decode it, and we get, not decrypt, decode. We get a user and an AWS machine. Okay, that could be nice. Let's try that out. Let's create an SSH key from that first part. We're going to SSH into this. Before we do, we better write that SSH key to disk. So I'm going to write this to disk. I'll set the permissions nicely so that it's so that the SSH client won't complain. I'll say use this SSH key to SSH into this host as user Ubuntu, and look at the flag. Whew, you've made it to the machine mainframe, 4th flag. And then we've won, but for extra credit, can you get credentials to take over the whole cloud environment? Well, cool, let's try that. So I've cleared my screen, and I've got those secrets. I'm on that WordPress pod. So from that WordPress pod, I'm going to run another command. So this command is going to run in a developer pod. And the reason I want to run in the developer pod is in case it has more privilege than the than the folks in marketing get. So I'm going to curl this special IP address, and this IP address is called the metadata API. It's present on all the large cloud providers, and it gives you information about yourself. Again, all this cloud computing, it's just really cool because the whole idea is when you're operating at scale, you can't just assume that you can't assume that you have that you have coded in what host you're on. You got to be told. So we'll ask the metadata API to tell us things. So and the metadata API will be different for each provider. On this provider, and this is Amazon, I'm going to go and reach out and say, latest metadata, I'd like to know from the IAM service, what security credentials are available to me? And my command runs and it says, your security credentials are master.cluster.bust-a-kube.com. That's your account. Well, cool. How about if I then say, let me pull credentials for that. And what I'll get out of that is basically what I need to make API requests. So I'm gonna pause for a second. Looks like I've already moved on, but I'm gonna pause for a second and basically just talk about what do you get from that. So if you've got the credentials, and luckily these time out after a little while. So in showing them to you, I'm not giving you my my cloud account, but these happen to be the credentials for my root user on the AWS account that hosts nothing but this cluster. But what that means, if we were looking at if this was real and we were looking at a real company, and somebody had used a root user or a highly privileged user, we at this point can do anything we want. We can access all their storage, we can destroy all their storage, we can modify all their storage, we can administer all the machines. Heck, if like I've seen a pen test where basically getting this API key was game over. This was the point where it's like, okay, well, I'm gonna make a snapshot of all your running systems. I'm gonna stand up duplicates of those running systems, or I'm gonna stand up my own versions and mount their drives and go and grab all of the hashed passwords and so on, get any data I want, and then I'll authenticate to the real ones. I'll modify anything I want. I own your entire environment. I can destroy or modify your entire environment. It's game over. So that's why this part's really, really fun. So I'm going to switch back to PowerPoint now and just talk about our attack path. So this is where we went. We gained an interpreter in the WordPress container. We moved into the MySQL container, got second flag. We used the MySQL container's unfettered network access to reach a kubelet on the master node. And then we used the kubelet's lack of authentication to invade the development department's dev web container, reasoning that the dev sync container in the same pod might be used to synchronize content. We checked and saw if there were secrets available. We found the SSH key and the account in the machine to get to, which authenticated us to the High Valley developer machine. And then we went back to the cluster and checked to see if the placement on the placement of that dev web pod on the master meant that we would have access, really good access on the AWS API, which we did, which was just cool. So that's our main attack. I'm going to show you a little bit more later on, but right now I want to go and talk defense. So let's talk about the defenses you've got, and we'll show you how to break the attack paths we've just seen. So the first thing is you have to upgrade your Kubernetes cluster. The big thing to understand is that Kubernetes is moving fast. There's basically a release every quarter, and they generally release patches for the last 3 versions or so. So there was a high severity vulnerability that came out today, and 1.14's current. 1.10, lots of people are in 1.10. There are, you can patch 1.14 and 1.13 and 1.12 and 1.11. If you're running 1.10 or 1.9 or anything before, there are no patches available, and that's basically what your support period is. This is kind of, I'd like to say it's basically shorter than on your smartphone, which was way shorter than your desktop operating system. So now let's talk about defenses. Once we've gotten past the hey, you have to patch, and hey, you have to upgrade, we have first you can basically set up when we look at the kubelet, there are a few things we can do. If we set up an authorization plugin on the kubelet, we can make it so that the kubelet, so first that the kubelet won't run commands for us, and we can also make it so the kubelet won't be allowed to modify other nodes. We won't be able to use the kubelet account to modify other nodes. I'm going to show you a demo. I've got these up on YouTube if you download the slides later from InGuardians website. But here I'm not playing them from YouTube. I'm playing them from my own platform. So let's take a look at securing the kubelet. So here we are. I'm just adding anonymous auth equals false. I'm adding an authorization mode webhook, and I'm restarting the kubelet. And this is just on one of the nodes. And then when I try that same curl command I was doing earlier, the 10250 run dev pod dev web command ID, I get unauthorized. So that breaking that way of executing code in containers that don't belong to you is that easy to cut off. I'm going to keep talking about more defenses that we've got access to. So another defense that we'd have is basically what's called a network policy. It's basically making a default. So network policies let you make firewall rules, in essence, that pertain to the pods. And the big one that's missing by default is egress. So what we saw, given that from a pod, I was able to go and talk to a kubelet, or later on from a pod, I was able to talk to the metadata API. What that means is my pod's actually able to reach my control plane, and my program running on the cluster, shouldn't be able to reach the control plane. Well, unless I wanted it to, but then I should have to spell that out. I should have to spell that out myself. And honestly, a pod should never have to talk to a kubelet. So if I set up a default deny egress, and I've got a nice little demo for that, then my pod doesn't get anywhere. So let me just full screen that for a second. So here's that curl command working. Now I'm going to create a network policy, and a network policy is just a bit of YAML, and it says, hey, I'm a network policy. Here's my name it anything you want. I'm going to apply it to anything in this namespace, and I'm going to say that this policy is going to be applied to any pods that match these labels, the WordPress label and the tier MySQL. So this is just for my backend MySQL pod. And I can specify ingress or egress. So here I'm going to do egress and basically say nothing. And I could, if I had valid egress, I could set that up. And so now when I apply this with kube control apply, now I've got that. And if I rerun my curl command, I don't get anywhere. The curl never connects. So that's our next defense. Back over to the slides. So network policies, here's just the quick theory. You just saw this, but basically network policies let you set firewall rules. We just saw an example where we said we're going to basically apply this. We have to say in what direction ingress or egress. We have to say what pods to apply it to, and then we say who's allowed to get in. We can also specify ports, but honestly at this point I didn't have to do that. So there's another. I want to keep going through defenses. If I think about the case where I was in the first marketing pod and I got into the marketing MySQL pod with an exec, I shouldn't have been able to do that. The only reason I was able to do it is that there wasn't a strong RBAC or role-based access control policy. So I can create an RBAC policy, and you basically go, and to do that, you have to create roles. You have to create service, you create service counts for each pod or service counts in whatever way you want. And those service counts should then have very specific things they can do. And so the way you specify what a service account can do is you create a role, which is a set of things you can do. On the left side, we see that we're creating a role called ing pod getter, and it's only in the InGuardians namespace. And that role says that anything that has this role is allowed to get pods. So a service account can have more than one role, and a role can belong to more than one service account. And the way I connect a role with a service account is through a role binding. On the right side, you see I've got this role binding, and it says, okay, This one's called front end is a pod, front end pod getter. If I had more space, I'd call it front end is a pod getter. And then I refer to a role. So this role ref that says, I'm going to refer to the role named ing pod getter, and I'm going to apply that to the subjects and one or more subjects. In this case, it'll be the service account named front end. So that's an example, and we can see how that works in a demo. So I'll switch back over, and here we go. So here I'm doing this kube control exec into the MySQL. That works. So now let's back out. Let's go to the master. Let's go to any node actually, and I'm going to apply some YAML files. So one's creating a service account called WordPress. Another's creating a role called getPods for marketing. Another's creating a binding that binds the WordPress service account to the getPods role. And now I'll take those, I'll look at my deployments, the pods, the things that are deploying those pods, and I'll delete my WordPress deployment. And then I'll reapply it, but I'm going to reapply it with the service account defined, instead of being the one it had, it'll be defined as one that has its own service account called WordPress. And I'm going to show you the contents of those. Here's the role binding. Just like on the slides, we have a getPods is bound to the service account called WordPress in the marketing namespace. I've got my role. So here I'm just naming the role. So naming some things that role can do. It can get and list pods and logs. And I've got that deployment where if I look in this new version of the deployment, I'm naming a service account. And so now, once I've applied that, if I try my same thing where I'm in the WordPress pod and I try to exec in, it fails. And that was my goal. So, a little bit more, you can, creating those service accounts, figuring out what should each pod be able to do. The nice thing is if we're dealing with WordPress or MySQL, they shouldn't be able to do anything on the cluster except basically exist. But if you do have something like Jenkins or what have you that needs to be able to deploy new pods to the cluster, or other programs that need to be able to interrogate the state of the cluster, you can create service accounts. Now it can be maybe a little tedious to figure out all that much, although I think it's really fun to learn that much. But there's a great tool in my Linux lockdown classes. I teach SE Linux and I teach a tool called Audit to Allow. There's a tool called Audit to RBAC, and what you do is you basically, this thing works the same way Audit to Allow works. You try to start a pod with its current, with a minimal service account, and it'll fail because it needed X privilege, and Audit to RBAC will add that privilege to the service account and then restart the pod. And it'll do that looping through until the pod starts just fine and runs just fine with no problems. And it's a really cool tool. If you look at Jordan Liggett's GitHub page, you'll find that tool, Audit to RBAC, and a video that shows you that in action happening. There's another cool defense called the service mesh, and Istio is the big example, and that's where none of the network traffic is allowed, where no traffic from one pod is allowed to reach anything without having to go through an encrypting proxy, and that encrypting proxy centrally manages what's allowed to talk to what. And it's an open source tool that you can get. I've got another defense that I like to use, and I'm trying to decide. Let's see. I'm going to show that to you. We may skip a couple slides today. So I'm going to show you AppArmor, and that is I have one attack where you launch a pod on a cluster, and that pod can mount the host's file system and then can go and read the shadow files. So what I'm going to do is show you just the defense side of that. And what it is I can set up AppArmor, and I can basically create a profile let me just get that in front of me, VLC. Playlist. I was in full screen mode. There we go. So I've got AppArmor, and what I can do is basically I can take the program that's running in any given pod, and I can create a profile around it. And that profile will name any file system access that the pod needs. And once I do that, I've got this kernel level protection that's stronger than just the container itself, that says what files a pod's able to write to. It also does more like root capabilities and network traffic. This is the profile for a syslog daemon for our syslog, and it basically says the cool thing about AppArmor is it's really easy to read. I love AppArmor because I can basically teach anybody to write an AppArmor profile in an hour. And there are tools that generate them automatically, but you need to be able to read them. And basically, this is a profile for our syslog. It just names all the files that our syslog needs to be able to read or write to. And if I apply that to a pod, if I apply that AppArmor profile to a pod, and I've set up my this attack pod that I normally use to read the shadow file, and I've given it an AppArmor profile. So here's what happens. So I've got a root shell in a pod. That pod's mounted in /root, the host file system. I'm running as root. I should be able, if I can mount the host file system, I should be able to read shadow. But when I try to read shadow, boom, permissions denied. Even though I've got all the other access, like I can actually still list Etsy, I just can't read it. I just can't read any of the contents. So I'm going to switch back over to my slides, and I want to show you a surprise tool here. So I'm going to blast through a few of our slides and then get back into demo. So big thing is, in essence, the AppArmor thing we just did is one of many things you can do with pod security policies. So once you're done with RBAC and network policies and securing the kubelet, the very next thing, the next intermediate to advanced step is to start saying, you know what, I'm going to make it so that anything that runs in this cluster has to run within certain policies. And I have, this is a list of 7 different kinds of ways you can constrain pods that run in the Kubernetes cluster. None of these are default. One of the big ones that's really useful is root capabilities. And that is, if you have anything running as root, you can actually name which of root special powers you want the pod to have, and it'll have none except for that. The biggest thing is the first bullet on this list, net bind service. It turns out most things that people run as root only need to be able to run as root to listen on a port below 1024. So you can start up things, and a cool thing to do is basically to start a Docker container that's running as root but only has net bind service. It'll be able to bind to a port below 1024, but it won't have any of the other root powers, like the ability to write to files it doesn't own, or the ability to change user ID to to a different user ID, or to kill programs it doesn't own or whatnot. So you can basically say pods that run on my cluster are only allowed to have net bind service, or a few other of the root capabilities. Another thing you can do is use seccomp, which has been made really popular by the Chrome browser, where you say, listen, when this program runs, the only system calls it needs are these ones that I've profiled using strace. So why don't I lock it so that it can't use any syscalls except for the ones that it normally uses, the ones in the profile. So we can create seccomp filters. I teach you how to do this in my classes. The earliest work on this was pioneered by Jess Frizzell, and she has a great blog post that's in the slides on how to do that. There've been some great tools that have come out since then that have made it even easier. Another big thing you can do is look at the Center for Net Security's benchmark for Kubernetes. It's really useful and basically details a ton of small settings that you can do. There's a tool out there called KubeBench that can check a cluster against that benchmark. Another one is if you're running in a cloud, you can try to conceal the metadata API, and I've got a few links for you here. And then I think the last thing I want to talk about before we get to demo is basically image safety. So whenever you're starting up containers, you're basically using container images. If you're pulling them from Docker Hub, if you're pulling them from wherever, it's really important to know who created them. Are they being patched? You can check them for vulnerabilities with an open source tool called Koros Claire. It's just really important to understand where those things are coming from and realize, just like just like apps you might download for your phone or what have you. You need to know who made this and do you trust it. So I've got some further references, and with that, I want to get into showing you a tool that we're doing we're doing a developer release on right now, and this tool's called Peratis. And Peratis is an attack tool, much like when you're using Metasploit with Meterpreter. You have the Meterpreter shell is your remote access Trojan, and lets you do things and do things more easily on systems you've compromised. Peratis is that kind of attack tool where if you find yourself in a compromised pod, and now you want to do the same kind of things you've been watching me do, I'm going to show you a couple demos of what it does. This is this tool that we've made to make those things easier, faster, more automatable. So Peratis is this tool that we've been working on at InGuardians. We have a team of 4 of us that have all been developing it together, and we're continuing. We've been through, we're developing and we've been doing internal releases, and we've been through about 21, I think, internal releases at this point, adding features. We'll start making greater hay of it out on the internet as we get further and further along. We just honestly keep having this, I want one more feature, and it's been really fun. Thanks to Faith Alderson, the other 3 people here have all learned Go to make this tool, and we've all really enjoyed that. So I'm going to show you a couple demos. Any of the demos you've seen today, if you download the slides from InGuardian's site, and we'll put the slides on InGuardian's site later today, you're going to find that there are links to the YouTube videos of each demo, and you can go back and watch them at whatever speed you want. So I'm going to show you our last 2 demos before we wrap up. So this is our first demo, and this is Peratis running. This is an earlier version of Peratis, and it's running against an on-prem cluster, so a cluster that's running, in this case, in VMware. And it has this, we basically built it so it's got this kind of, tells you at the top, like, hey, here's what service account you're running with. Here's where I got it from, or here's what it's named as. I found the certificate authority. Here's the API server. Here's your current host name, your current pod, what namespace you're in. What do you want to do? You can like list things, or you can move around to other things. So I'm going to go and say that I want to get a list of pods. It shows me a list of pods in this cluster. And I'm going to say, give me complete info on all the pods. Do that kind of, running pods thing. And we get a JSON structure back, and I can go and read through and read about them. And then I've got a number of attacks. So one of them is I can say, okay, get me the secrets that the API server has. And it says, hey, I found 3 secrets, and all 3 of them are service accounts. And I can take one of those, the default token here, and I can now say, I'd like to get a service account token out of that secret. So I paste that in, or paste in the name of it, and it goes and grabs it. It base64 decodes it, and then it stores it. And then we can start using it to do things. So I'm going to go and say, okay, well, show me all the service accounts I've gathered, and I'd like to add a new one, and I'm going to add that one. In this version of Peratis, we weren't pulling it in. You had to paste it in. So you'd name it. So name a default secret, and I paste it in. And once I paste it in, Peratis can now run with that privilege. So I'll go and switch to that. Switch over to that secret. And now once I've switched to that secret, I'm in default secret. Default on Kubernetes generally means kind of just basically root available. And so now I'm going to go and do something else. I'm going to go and take a look and find out what my IP address is on this system. And I'm on a Kali system, and I'm going to set up a listening shell on port 80. And so I'm 58.141. So I'm going to go back over into Peratis in my other window, and I'm going to use 20. So 20 is compromised, and it says I'm going to gain a reverse root shell. And the way I'm going to do it is I'm going to launch a pod that mounts a path on the host, and on that host I'm going to write into the cron tab file a command I want to run, and that command will be a reverse root shell. So I want it to connect back to 141 on port 80, and Peratis says it's deployed that pod. So it's found an image, it's copied an image that was already on the cluster, it's modified it to mount the root file system, and used it to write cron tab. And if I listen on this, I wait until the cron tab, so up to a minute, because it's basically going to run this once a minute. And what do I get? I get my root shell. And so now I'm root on the node. And I can do this to all the nodes, and I basically from here own the entire cluster by owning its nodes. And so from here, if I want, I can go and cat out etc password or etc shadow or what have you. So that's the first, that's our first Peratis demo. Our second Peratis demo happens against GCP. And I know I'm about to run over time by a minute or two, but if you bear with me, I promise it's worth it. So I'm going to run Peratis again, and now I'm running a future version of Peratis, still about 4 versions back from our current. And here, this is the cluster we were in that demo that I showed you. So we're marketing WordPress, and we've got that loaded. This is our host name. We're in that first pod. So now we're going to go and say, hey, I'd like to ask for the IAM credentials from the GCP metadata API. So I'm going to query the metadata API and ask for the cloud provider account. I get that cloud provider account. Well, that's nice. Well, how about if we go to attack 15, which is I'd like to pull the Kubernetes service account tokens that might be stored in Google's cloud storage, and using those credentials that I just pulled. And says, okay, do you want to store them or just retrieve them? I'll store them. So Peratis goes and uses those credentials, uses the cloud credentials to read GCS to find all of the service accounts that were used to build the cluster, including the admin. And so then when we list what service accounts we have, it's automatically stored. So let's take that. We have admin, we have kube, and we have the kubelet. Let's take the admin one, because honestly, that's all I need. And now I've got full access in the cluster. And just to show you what that means, I'm going to switch namespaces over to kube system. In kube system, I shouldn't have had any privileges. I didn't before. So now I'm in kube system. I've got my admin account. And now I'm going to run a command in all the pods in kube system. And what command will I choose? Well, let's run ID. Yep, I've got command execution in every single pod, that makes up the Kubernetes infrastructure here. Now, there are a bunch of other things I can do with Peratis. The whole idea is to let me basically keep escalating privilege and switching privilege and finding out what can I get access to, what kind of secrets do I have, getting access to underlying nodes if I can, and we're just constantly adding features to this. We're really, really excited. If you want to help out with development, or you just want to see what we're up to, I will. Oh, darn it! I've switched past my last slide. Then, wow, where's my URL? There it is. I think I skipped right past it earlier. So head over to InGuardians.com/Peratis. So recognize we're on a developer release, so have some patience with us. I'm sure we know we don't have the kind of bugs where the feature doesn't work, but we'll surely have bugs when you're not permitted to do something or what have you. Last thing I want to say is that we have at InGuardians a weekly executive briefing, and I really like to tell everybody about it because we take a lot of time to write really, really useful technical content that's useful for everybody from the top of the organization and the C-levels down to the folks who have to fix the thing that's broken. So take a look at our briefing and come to our next webinar. So thank you very much, Mike.
Thanks so much, Jay. I really appreciate it. And definitely keep in touch. We are doing one webinar a month. We've got a webinar coming up next month in about 3 weeks with Justin Searle. That's going to be fantastic. It's all related to ICS environments. The space is filling up quickly, so make sure that you register for that one. And the following month, we're going to be doing a red team primer for executives. Thanks so much, Jay. I really appreciate your webinar plus the demos. Lots of fun. Make sure that you go to check out Peratis at InGuardians.com/Peratis and sign up for our newsletter. Thank you so much.